You've seen already how when waves change speed they can change direction. What I'm going to show you is why that must happen in terms of looking at the wavefronts of waves that are crossing a boundary in a ripple tank. So here we have deep water, and in the deep water you might remember that waves travel faster. Here we've got shallow water. In this the waves are travelling slower. So I've got a series of wavefronts that are heading towards that boundary. Remember, wavefronts are the crests of the waves. We can see here the waves are heading towards that boundary there. So I'll just quickly draw these in. I'm drawing the waves, trying to make sure that they are evenly spaced because they've got the same wavelength, haven't they? They've got the same speed, but the same wavelength when they're in the deeper water. I've got to this one here, the last wave that is just travelling in the deep water. So what happens in the next part? Well, in the next fraction, this part of the wave is still in the deep water, so it's going to travel the same distance. So I know that this bit of the wave is going to get to there. In fact, all of the bits of wave that are in this part here are going to have travelled that distance there. But this bit of wave is going to cross over into the shallow water. When it crosses over into the shallow water, it doesn't travel so far. Well, I've set this up so that when it crosses over from the faster, deeper water into the shallow, slower water, the speed halves. So here I had it that between waves it was 1 centimetre. Now I'll have it that it's half a centimetre. So if I draw it in there, I know that that wave, that bit there, is only going to go that far. So what does my wave front look like? Well, you'll see that it's no longer a straight line. This part of the wave has been in the deep water, travelling at the same speed. This one has slowed down. What happens in the next fraction of a second or so? Well, this bit of wave here is still in the deep water, so it's still going the same sort of distance, but this bit of wave here is now slowed down. So that bit of wave there has been in the shallow water, has only progressed that far, so it only gets to there. So I know my wave front must go like that. This bit has been slowed down and gone like that. Let's have a look at the last bit of wave. Well, now this bit of wave just gets to there, but all of this part of the wave has been travelling in the deeper water, been going slower, and so I'm going to join that up like that. You'll notice two things have changed about the diagram. One, the waves are closer together, and two, they've changed direction. Right, well, let's have a consideration. Why are the waves closer together? Well, were any of the waves destroyed as they crossed the barrier? Did any of them disappear? And the answer is no. So we can say that for every wave that was in here, it crossed over to there. So what I can say is straight away, well, the frequency must be the same in the shallower water as it is in the deeper water. So frequency stays the same. What happens to the wave speed? Well, I said that the wave speed reduced. In this case I said that the speed halved. So let's have a think of what happens to the wavelength. Well, we have got V equals F lambda, frequency times wavelength. That's my equation. So if the speed is halved, the frequency has stayed the same, it must mean that the wavelength has halved. Yeah, of course, that's what happens. They're closer together, they're half the distance. Okay, so that ties in. But what you'll also notice is the direction of the waves. Right, let's have a think of these wavefronts. These, remember, are peaks of a wave, so as the waves are travelling, they must have been travelling down like that. So if instead of drawing in a wavefront, I draw in the direction, I know that the direction of the waves was at right angles to what the wavefronts are. So it is like that. That is the direction of the waves. What about the direction here? Well, it's at right angles to the wavefront, so it doesn't carry on as it did like that. Its direction of travel now at right angles to the waves is something like that. And there we can see it. We can see how the wave was travelling like that, then slowed down and now it's travelling in that direction.